This problem is from the casting, metal casting, and it says a cylindrical job with diameter 200 mm and height 100 mm is to be cast using modulus method of riser design. Assume that the bottom surface of the cylindrical riser does not contribute as cooling surface. If the diameter of the riser is equal to its height, then the height of the riser is. So it is a pretty simple problem, and what it says is, and how we are going to solve it. Let me solve it over here itself. There is a cylindrical job, alright. So let's say this is a cylindrical job, and its diameter is 20 mm, and its height is 10 mm. And from the modulus method, you must have seen m is equal to d by 6, alright. And how we get d by 6? It is nothing but, actually modulus is nothing but it is the ratio of volume to surface area, and where you minimize the surface area for a given volume, and then you try to establish a relation between two variables. Like if you're talking about the cylinder, there are two variables, that is the diameter and the height. So you have to design a riser which can, minimize the exposed surface area like that. So from here you know that the modulus is nothing but d by 6. So you can simply write it as 200 mm, sorry, it's 200 mm, not okay. So 200 by 6. This is the modulus. For what? This is for the casting, isn't it? MC. Now for MR, now it says that the bottom surface of the cylindrical riser does not contribute as the cooling surface. That means, that clearly indicates that it is the case of what? It is the case of top cylindrical riser, isn't it? Not the side cylindrical riser. So MR will be again d by 6, and we know that its diameter is equal to height. Diameter of the riser is equal to its height. Then the height of the riser will be. So d by 6 is nothing but, and you must be knowing about one thing, that modulus is actually used to calculate the solidification time, and the solidification time of the riser should be always greater than or equal to the solidification time of the casting. So let us talk about MR equal to MC. In the worst case scenario, the solidification time of the riser is just equal to the solidification time of the casting. It is not greater than that, for an assumption, although it is usually greater than that. So MR is nothing but d by 6, isn't it? We are talking about the riser over here. And what is MC? It is 200 by 6, isn't it? Now from here we get that d is equal to 200 mm. Now this is d is nothing but the diameter of the riser, and since the diameter is equal to height, it is given in the problem itself. So therefore the height of the riser will be 200 mm. And let us see, does it match with our options or not? Yes, it matches with the option B. So option B should be the correct option.